Welcome to our power transmission class, where we're going to be reviewing the book, Chapter 6. And Chapter 6 is a really good chapter. Very, very important chapter for not only for this course, not only for your degree, but also for your career. If you're going to do anything in mechatronics for your career, this is a really, really good chapter to read through, not once, not twice, but maybe 3 times. It's got really, really good stuff in it. So with that, let me show you the book. We're going to share my, switch my cameras, and we'll talk about the book. So in Chapter 6, we're talking about the beginning of Section 2. So Section 2 in the book gets into the mechanical knowledge. And this, like I said, this is pretty much half of the program. This thing touches on half the program. It's all the good mechanical stuff. And this is a very, very important aspect of tower transmission. And we're going to spend a lot of time in the lab playing with these elements, playing with the V-belts, playing with pulleys, playing with shivs and gearboxes and motors. So we're going to be doing all that in the lab. And it's pretty free form, which is why we want to give students as much time as possible. Only one student per lab per system. So you're going to be setting up your entirely own system. So in Chapter 6, we start talking about belts and shivs. Now that's the first bit of important learning. When you're reading the book, you don't recognize that that term is called a shiv, not a sheave. All right, and a lot of people make that mistake unless you're in the industry. If you know what you're talking about, you're not going to talk about those things that, you know, let belts and V-belts ride in as sheaves. You're going to call them shivs. And so that's a very, very important distinction. So as we get through this, make sure you use that properly pronounced, and you will be a lot smarter sounding to all of your compatriots when you first get on the job site. The book starts talking about flat belts, and you're going to see a lot of flat belts out there. The book mostly talks about power transmission flat belts. In other words, the idea that you have a drive side, a drive pulley, and then the belt's used to kind of convert the power from the drive pulley to a separate machine or a separate pulley. But in many, many cases in the real world, you're going to run into flat belts being used as conveyors. They convey material or boxes from one point to another, and there's usually going to be a drive pulley on that conveyor. And all the same calculations in terms of tracking and that sort of thing also apply to conveyors. The book takes you through a little bit of a background, talks about leather and rubber and canvas. Obviously, canvas belts are very old school as well. And so it takes you through the different sizes. It takes you through a basic speed calculation, which is very, very simple. And all I can say is read through this very carefully. We're probably not going to do a whole lot in terms of calculations in my tests on speed, but understand all these terms. Understand what light duty versus heavy duty versus medium duty really means in terms of belt sizes. You know, kind of read through all this. The second part in 6.1 is flat belt tracking. And once again, this is really, really good. I wish I had run into this years ago. It takes you step by step, and I can't highlight this. I want to highlight the whole page. It takes you step by step on how to do your belt tracking. And the first step is always do a measurement to make sure that your shafts are parallel, and the distance on one side of the shaft is the same as the distance on the other side of the shaft. And that's usually the best way to do it if you've got two shafts, your drive pulley and your drive, kind of a idler pulley are separated by a long distance. You have to use a tape measure to do that, and it's hard to get exactly right. Then it takes you through a methodology with drawings of using something called a witness mark. So as you track your belt, it wants you to start off really slow. If you speed it up, then the belt goes off quicker. So you start it off slow, make sure it tracks slowly, and then you speed up your system to make sure it stays tracking, and then you make adjustments as you go. So the book takes you through all of that stuff. It's really, really good. The book talks a little bit about the pulleys, the flat belt pulleys, talks about them needing to be generally larger than the belt. If your pulley is just barely big enough to run your belt on, then your belt starts running off even with a slight variation in the belt tension. Stretches a little bit, you're done. So you want a pulley that's big enough to have a little extra meat to run that belt on. So this is really, really good stuff. Read through that. I can't emphasize it more. Then on page 135, the book gets into V-belts. V-belts are probably more common than flat belts. Now, flat belts in the real world, you're going to run into a lot as conveyors, sometimes as power transmission, but more often as conveyors out in what we have in this region. V-belts are used everywhere. They're used for power transmission, for pumps, for vehicles, obviously inside your vehicle. I'm sure you guys have a V-belt that's running based on your engine, running power out to your fans and that sort of thing, to your alternator. V-belts are probably the most common power transmission tool out there, period, of any of them that you're going to run into. And you're going to have to replace these. These wear out. So if your V-belt needs replaced, you're going to have to know how to replace it. So the book goes through a whole process of how you install a V-belt. You will need to keep this book with you when we get into the lab. This will tell you how to do the steps in the lab. I'm not going to give you a separate procedure to follow. You will need to use the book. So bring the book with you in the lab. And you'll be using a tool like this to measure the force that you apply to see how far your V-belt's deflecting. So that is a very, very important tool. And here it gives you the rule of thumb that you will use to verify that you have the right tension on your V-belt. So this, I can't emphasize this more. I want to highlight this whole page as well. V-belts are critical, are absolutely critical for power transmission class. On page 136, we're going through the different belt styles, and all these belt styles, these different cross sections. This is to scale, I think. No, it's a little bit less than scale. It shows you all the different cross sections of belts and the codes that you use to order that belt. So if you measure up your belt and you find that it's a 1/4 inch across and the height of it is roughly 5/32, that we know is a 2L belt. So this is a really good tool to keep on hand. That's why you want to keep this book on your bookshelf. Starting on page 136 into 137, it takes you through all the different descriptions of what these different codes mean and why they exist. And that's really, really useful. This is the kind of stuff I wish I had a long, long time ago. It talks about double belts, for instance, this guy down here. And talks about what do you do if the information on the belt wears off. So then it talks about how you calculate that, the length of the belt, and that sort of thing. It talks about a pitch diameter. A pitch diameter is how you measure the length of that belt. You need to know the pitch diameter and where you would find that. It is not the outside edge of the belt. It is not the inside edge of the belt. It is the line on the belt that determines the optimal pitch of that belt system, and it is used for the measurement of the belt length. And they give you a great table in 6.1 on pitch lengths. So if you have a sort of a nominal length, you can calculate your different, depending on the belt style, the different pitch lengths. So, and like I said, all that's really good. Now, the rest of this chapter has got some useful stuff too. It talks about positive drive belts. These are timing belts. Typically, they're called timing belts. They're belts with little grooves on the inside to give you a little bit more force without necessarily having higher tension. And they maintain a certain timing between the different pulleys that run those belts. So it talks about those belts, talks about how they're made. In section here on page 141, we go through the different kind of pulleys out there. Talks about different parts of a pulley, different methods of attaching that pulley to a shaft. And there's a variety of different methods. Sometimes you have set screw, sometimes you get these fancy tapered bore pulleys. 6.2, chains and sprockets. Many of you guys have driven around bicycles. Chains and sprockets is also highly used in industry. Anytime you've got more force, like a lot of force, a lot of power that needs to transmit between one sprocket and another sprocket, that force, that extra power is usually going to be chain driven. Chains are great in terms of low speed, high power transmission. They're great. So this book does a great job, once again, of going through all the different standard ways of describing chains. So once again, I'm not going to emphasize anymore. Chain splitter is a useful tool for cutting open different links. I've used one of those many, many times. And a lot of my roller systems have used chains because they need high power. On page 143, we get into some of the more obscure chains, like a silent chain, ladder chains. Those are a little bit less common, but you can read about them and learn about them. Shows you a picture of a silent chain. Silent chains transmit power without making that clinking sound, but they're also able to work in a lower profile environment. Sprockets are the things that chains run on. So in your bicycle, you've got a front sprocket and you've got multiple back sprockets, assuming you got a multi-speed bicycle. And the book takes you through all your basic kind of sprockets. Doesn't really hit heavily on the whole sprocket thing, just takes you through some of the basic types. This is really important to be able to look this up quickly if you need one. 6.3 on the bottom of page 144. Let me just